Hi everyone, then I just started the session today. So today I'm going to share running your first automated speech recognition model on HuggingFace. So I'm Mia Chan. I'm from AWS, work as a machine learning specialist solution architect. What I do for my daily work is I talk with the customers around AI machine learning workload on AWS best practice. And I also do some enablement with my customers and also developer community. So today, before I start the talk, I would like to ask your experience on the audio machine learning. So how many of you already work with audio data on your machine learning project? Raise your hand, let me know. 1, 2. Okay, great. I think that's great audience because I put the first, right? So that means you're probably from 0 to 1 or from 1 to 1.2, something like that. So for this talk, I prepare for the people for interested on machine learning topics, audio machine learning topics, and also probably you're interested in the HuggingFace, the framework that I will introduce later. So let's dive into the content today. So for the agenda, first I will share you what is the ASR, that is automatic speech recognition. And later on, I will share my experience from how I work with audio data. And then I will share what's the model that today we are going to fine tune on, and also the data set that you can play around with. And also, I will share some code snippets on how you can do it with HuggingFace on Amazon SageMaker. The end of it, we can go through how to interact with the endpoint or test your model. And in the end, I will share you after the sessions, if you want to try it out, what could be next. Could be where to start coding, where to find more resources, and so on. So this is my agenda that I will go through. Yeah, so prerequisition here, I assume everyone is interested in Python. That's what I'm here. You are all here. And also, later on, I will share the Jupyter Lab. Have you worked with the Jupyter Lab, Jupyter Notebook? Raise your hand, let me know. Okay, my friend, that's great. And probably you are interested in machine learning and NLP. So that's my 3 prerequisites for this topic. So to start, to talk about ASR. For ASR, this term, probably most of you feel like not so familiar with what it is. And there's a more friendly name. It can called speech to text. So when it comes to speech to text, it makes it more friendly, right? You understand what it actually do and where we can use it in the real life application. So I put 4 examples here. First, you can use it to analysis your custom service call. So from some customers that I work with, they want to know what their customers are complaining about. So first they need to capture the audio, and later on, after capture the audio, they put it into speech to text. Get the text content and do sentiment analysis or text classification or intent classification to analyze the content later. And the second case could be the voice assistant, like Alexa, like Siri. They are the service that take your voice as input and make it to speech to text and make it more friendlier for your computer to understand what you are saying, and then put it into like instructions in the application, and then they book the hotel room for you, they do other things for you as your voice assistant. The last 2, I put it here for video subtitling and also transcribing the meetings. This 2 use case is the one that I like the most. Why? Because originally, when we are going to manage the video content, it's really hard to just find the correct video content just by search, because it's really hard to just search a video without knowing what is in that in content. So for people who are doing content management, it's really difficult if you don't know what the content it is. And for people who cannot hear it well, they need subtitle to help them understand what's the content in the video. So these are the 4 use cases I list here. Probably you can think more when you start your first ASR project. Now, I want to move to the next slide, work with audio data. So I also want to use this talk to share my journey. I remember when I first started the machine learning project, it was a while ago. But after some time, then I finally start my first audio data. What took it so long? Because I feel that I'm not familiar with audio data. Probably some of you also familiar like this one. Like for me, first I feel comfortable to work with tableau data, image data, because I can just see it as it is. And for the audio data, I don't know how to work with it. And later on, as soon as I work with more and more audio data project, I found out one thing that really helps me is to visualize it. When you see it, this one is only one sample, right? But when you work with audio data, you might work with human speaking, like I'm speaking, or you heard a dog is barking. And then the wave of it, when you visualize it, actually is different. And even I saw the interesting research is when we are speaking in different languages, like my mother tongue is Mandarin, so when I speak in Mandarin, like the sound wave is a bit how I speak in English. So the different wave that shows the different features and characteristics in each of the audio file. And that really helps me when I do like audio classification, that I know if they look differently, they should be categorized differently, right? And this is how we got intuition when we work with image data or computer vision data. That's how we get the intuition on it, and I apply this intuition when I work with audio data. That's how I started. And another one is, I take one example, is the HuggingFace. So HuggingFace libraries, it's a startup that they focus on the language use case, and recently they got more adopted to computer vision case as well. On HuggingFace website, you can find model, you can find data set, you can find other people are sharing how they use this data set and this model to do their project. So this is really helps me to see how other people are using audio data to do their project. Because sometimes we don't start it, could be first you feel really far from the project, or the second one is you don't have the idea what are you going to do with audio data. So that's where I got my inspiration from. So probably later on when you start it, you can also visit HuggingFace website to see it. So I want to dive deep a bit about what is HuggingFace libraries. So when you visit their website, you will see it's open source data sets, transformers, tokenizers that you can use it in your project. And it's also a popular library since it has more than 65,000 GitHub stars and tons of downloads per month. So with this a few data points, I would like to show you if you would like to work on some NLP project, no matter it's text analysis or like audio analysis, this could be the place you can start to play around with it. So depends on your work environment. If you are the one that happy work on your computer, then open source framework that you can just work on your computer, right? And if you are the one like me, I'm working on some cloud environment, you can also run this workload on a cloud environment as well. It really depends on which tech stack that you're familiar with. So before I dive into the code sample, I just want to highlight, like when you starting work using HuggingFace to start your first ASR model, what are the things that you might need? First, I'm sharing you need to start, initiate an estimator. So when you start to initiate an estimator, that will shows where you can find the training script, where you can find your source code or your source data, and what are the computer powers that later on you're going to run on your training job. So these are the details that you might want to put in there, and then when you start training the model, you just run HuggingFace estimator and fit. So it's like other project that you work with scikit-learn, you have the estimator and then .fit, then you will start training. Okay, any questions so far? Oh, good. Okay, then I will switch my monitor to the notebook one. I hope you can see it well. Do I need to zoom in a bit? I think for the image part should be fine though. For people in the last line, I see you're nodding, that's great. So this notebook, And the content that I share today is one of the artifacts that from my colleagues, and I did the tech review for the content for this. And I think this would be a great start point for people who want to start your audio project. So let's start from the background. What is the model that we use as a base model to fine-tune with? So the base model is called WAV2 VEC2. What it does under the hood, I shared it for these pictures. The first, you have the raw audio. It's like the wave like this one. And then later on, we will send the audio file to the feature encoder. So after you got the feature encoders, that makes it from the original audio file to the vectors that computer can understand. Later on, you bring these features to transformers to do the context network and got the tokens for CTC algorithm later. And what I really like is later on, if you want to dive deep on what is CTC, you can click the link that later on I can share in the Slack to dive deep on what's under the hood for CTC algorithm. And why I like this algorithm is when you prepare the speech-to-text data, you only need to provide audio and transcription, and you don't need to provide the timestamp. Is it awesome? Right? Because you don't need to annotate it till like which second that I speak which word. You only need to just end to end, like one audio file, what's the contents that I speak. So I think this is a really great start for people who are lazy for annotation, and then this is a good way to start working with CTC. And for CTC, it's not only work when it comes along speech to text. It also works when you are doing handwriting recognition. So remember, like in the beginning of the talk, I'm mentioning when work with audio data, I also take my experience when I work with computer vision projects. That's also applied here. When you see the CTC algorithms, it's an algorithm that apply both audio use cases and handwriting recognition, which comes from computer vision use case. So you can use your previous knowledge to learn how to start an audio project like this one. Okay. And later on, what are the components that within this notebook? It's about first, we will load a data set. Okay? And for the data set itself, it comes alone, it's called Speech Processing Universal Performance Benchmark. It comes along with, I remember it's like hundreds of hours. Let me click this one to dive deep. So the website that you're seeing right now is the HuggingFace website. And then if you go to datasets that you can find here, for each of the datasets on the HuggingFace page, you will find several things. First, what is this dataset about? Another one is what you can do with these several datasets. So for instance, in our case, it would be automatic speech recognition, ASR. So that means if you want to run an ASR task, you can use this dataset. It also come along with other audio tasks like keyword spotting or other audio classification and so on. So in the dataset page, you can always find several tasks here and task category here. And most importantly, is the language. The case that I share today is dedicated for the English case. And I know since we are in Europe right now, so they are like multi-language in Europe. So there are some data sets that come along with multi-language support. And for this data set, it's dedicated for English case. Okay, let's go back to the notebook. So first, this is our data set, come along with tons of audio files, and then later on, we are going to use a tokenizers to make it as a separate alphabet, and then run the feature extractor to make it more friendlier for computer to understand it, and later on start a training script, split our data set to the training and test data. And later on, you can use HuggingFace DLC, deep learning container. When you deploy it, then you can run model input and prediction and output. In the end of it, you can have an endpoint, which is the model as an inference that you can use to serve your external users. So these are the end-to-end process for this one. Okay. To start, I will need to start a kernel for this. Yes? Oh, please.
Could you elaborate a little bit more on the, I think in the earlier diagram you had it labeled as CNN, but I think it's the bit which does the pre-processing. Could you just elaborate on what's going on in that box, please?
Mm-hmm.
And so it would be the one which is labeled here as CNN. Yes. If you can just explain, just briefly, what's going on in terms of how you do the feature extraction, please, in that.
Yeah, sure.
Flow, please. Thank you.
So for the feature extractor that you can think of like from the audio file itself, originally it come along with the waves that we see in the graph. And then in the feature encoder, usually what we will do for the pre-processing, sometimes we will do Fourier transformer, some mathematics class that you might left in your like college. And then later on, when after you do the transformation, that you got a series of the vectors. And then later on, depends on the model that you run with. I'm sorry about that. Okay. Depends on the model that you run with. After you run pre-processing, and later on you want to run the encoder. And then encoder depends on which encoder that you run to. It will become encoded to different dimension of the vectors. So it really depends on the use case, and also depends on the network that you're going to run later. So for instance, later on, if we are going to call the transformers, then there's an input dimension for the transformers, right? So in the feature encoder, that you have to make sure your output of this encoder is the input for the context network. So it's kind of like, I would say the feature encoder or pre-processing is kind of like hacking way, because first you will select which model you want to work with, and then you work based on the input that you need, and then you kind of, twitch the audio file to the input that you need for that. So that would be the things that you need to do.
Okay. Do you have to convert the audio signal into text in any form when you get to that level?
In this part, you don't need to convert the audio file to text, because this part still applies that from the audio wave, that all the numbers that you got, and then convert to vectors. So this part is only the audio file itself. And later on, when you work with transformers and CTC, that's where you come along with the transcription that is your label data. Okay, great. So I get my kernel started. So because our session is only like 45 minutes, and this model, if you run at home, it will take 2 hours for training. I will not wait here for 2 hours. I think you will also. So what I will do is kind of like the cooking show way. So if you have watched the cooking shows, you always see like someone cutting the onions, and then later on they said, oh, I'm going to wait for the onion to be cooked, and they just put the cakes on there because that's something that they made before. So that's also what I will do today, is like the cooking show. I will show you first how it's run, and when it goes to training part, I will just stop there and bring something that is pre-cooked, and then you can know how it works in general. So I don't know if the last row of people that you can see it clearly. I can just briefly go through what I do for each of the code block here. Usually first, you will specify which libraries that you're going to use, which is like SageMakers and transformers, and also libraries, torch libraries that later on I will use. And for the Librasa, this one is the libraries if you want to work with audio data. And later on, you will also need the sound file that you can work with the audio file as well. And what I do in this code block is using the SageMaker sessions, which is the service that I'm running right now, to get my sessions so that I can use it to interact with AWS S3 or other storage that I put my data in. It will take some time since it's still doing the environment setup here. Regarding the data pre-processing, regarding the question that you asked, there are like two parts. For instance, all the data set you got from online, they probably not for your own purpose. They probably just put there for everyone can use it. So when you download this data set, you found there are actually a few schemas that you are not using it. So you only select the features that you need so that the rest of the features can be done by that. So for instance, in this of the data sets, they have, I remember it's 5 or 6 columns on it, but then we only need 2 or 3 of it for each of the speakers, what content they speak, and so on. And later on, we also do the trend test split here. Regarding the test size is 0.2, you can always change later. And then you can also print it out to see what's the data set trend, the first entry will look like. Give me a second. Okay, so each row you can see, I'm not sure if you can read it clearly, but I can walk you through each of the data point in this data set. The first will show you where is the data, where's the file path. Next, what's the array? The array, that is the value for that. And what's the sampling rate? The sampling rate is 16,000 Hertz. And this one would be people, if you work with audio data set, you will see how people doing the sample rate differently. Some people were doing 16,000, some people were doing like 8,000, depends on the data resources that you have. And remember, if you are doing the sample rating 16,000 here for your training set, when you deploy your model to production, remember, when you got to the new data, you should also resample it as the Hertz that you have here so that you can have the best performance for your model. Okay, so let's work through the data points. And here, I put a little bit mathematics on formula here that I just want to share. This CDC model is good for both speech recognition and handwriting recognition. And what it does is, as you know, for the handwriting, there are like continuous the handwriting when you do it. That's the same when you are speaking a word. Like when I'm speaking a word that actually I'm pronounced, let's say, if I say a word, there's a method. So it's like method. It's like, sorry, I don't know how to disconnect it. Probably you also cannot, right? And how we speak and how we write, they just continuously like put the data point together. So these algorithms help us can separate them. So even I said method, but later on it can separate this METHOD for this case. And then for the handwritten one as well. If you write method, then this algorithm can help you separate it as separate alphabets. Okay. And then here we do the extract information. Here what it actually does, let me open a vocab JSON file. So because I mentioned for the CTC algorithm, it will map continuous audio file to each of the alphabet. So you need each of the alphabet here as encoding, and also there are some path or unrecognized ones, so that later on when you work with it, you can have space in the middle, or you can have like the blank token in the middle. So it's the one, blank and unknown. So these are the token that we are talking about right now. And after we got it, the JSON file, later on we will run through the transformers for tokenizers and feature extractor. So this is where the transformers run through the file that you'd have and try to have the tokenized and extract the feature so that you can run it later in your training set. Training set, seems it will take some time. Yeah. When it's still loading, I want to share one thing is, so for the audio project that usually it will come alone with a few audio sample data. And most of the data that comes along with the combination of different, let's say, men and women, kids or elders, like when you are picking the data set itself, you are actually picking up the different combination of the data points that you collect. So be mindful with the data set you pick not necessarily reflect the data points that you have from your upcoming new customers. So from the previous session, I think it was from Theodore's, talked about like testing stuff. And when we rolled out a machine learning product on production, that's also something you might want to be aware of. The data set you train is kind of ideal environment. And you probably have equally class for each of the users, like 25% for kids, 25% for teenagers, 25% for people mid-age and elders. So you have it equally. But when you launch in production, probably like 70% of the users are kids. So their pitch are really high. Is like not the normal pitch that we have as like adults, right? So once you find something, it goes differently as you expected on production, then you can always reevaluate it to think, is this the correct data set to start with, or we already got to the new data point so that we can update our model later. So the machine learning project, it's not like make one and you just put there for 100 years. It's more like you make one, you test one, and then when you put on production, you continuously monitoring to make sure it fits your user's need. Okay, this one takes like the ages. I've already talked about like roll-up production things and still in 23%. So I will just continuing, not blocked by this one. Yeah, the data set is not defined yet because from here. Okay, I will go through the code part for when you start this training block, what happening under the hood. I take Amazon SageMaker example, and you feel free to kind of change this code to whatever platform that you're working on. What it works under the hood is taking the estimator, that HuggingFace estimator with the framework that we just mentioned, Web2, Vec2, and then put it as a container that SageMaker will start a training job, which is start some instance remotely, start your training job, and during the same time, you can close this browser because that's a job we create remotely. And then after you finish the training, you can go to the place that check your training job to see if they are complete. So you can always come back and revisit when your model training is done. The training script here, it comes along with the script and train. So if you are the one that interested on what happened under the hood, feel free to visit this trend and the Py file. In here, it covers what are the tokenizers, what are the things that we take care for, like the model setup and training setup. And here are the metrics that we run through it for the ASR recognition and the trainer and the model and so on. So this will be the code snippets later on you might want to visit too. Was that questions or just stretching? Yeah, I was just seeing someone like relaxing. That's good. Till the end, let's assume our training now starts, and then after we run this, estimate the fit. After 2 hours, you got your model trained. What happened afterwards? Then you need a snips for deploy your model to endpoint. When you deployed it, what you need to make it happen, first, mention about what are the codes that you want to run on as an inference, where you can find the model artifacts, and what are the transformation versioning, PyTorch versioning that you use, and in the end, you would have an endpoint of it. And in the end, you can also have the audio file here that you can test it out with your endpoint. So the idea will be when we go through it, the web file that you can always turn on from, I think from this one. Let me check.
She had your dark suit in greasy wash water all year.
So when tried it out with the audio file here, then the endpoint as a predictor that shows the transcription under here. So the idea would be when you fine-tune the model, the output of it should be the transcription of the audio file you just put in. Remember, if you train with the .web file, it should come along with .web file. If you train alone with 16,000 Hertz file, you need to resample your data to the same Hertz so that can be a best performance. These are just the minor things I would like to just call it out. Now this is the end-to-end code samples snippets here. Any question regarding the code samples? No, not yet. Okay, so later on, I can share this code sample in our Slack channel so that later on when you go through it, if you have any question, you can reach out to me offline. And another thing that I would like to share is the notebook. So from the conversation that we have, actually, I've already got through most of the things I would like to share. What is ASR? I hope you have the clear idea what is ASR for and what are the applications that you can find ASR model within it. And perhaps in your mind, you already start to think about how you're going to use ASR in your side project. And later on, I share a few tips about when you load the dataset, what are the things that you might need to notice, and what are the things that you can check, especially like from the HuggingFace estimator, how to start it, how to start a training job, and in the end, to interact with the endpoint. And for me, what interested me the most is like before today's conference, like yesterday, I also mentioned this conference to my colleagues and mentioned about I'm going to share ASR model using HuggingFace and using English model. And then my colleagues who work with French customers, then we start to find the resources. Can we also adopt this one to our German customer and also French customer? I think that would be super cool to see the next step for this one. And how about the multi-language ASR? If you go to visit the HuggingFace website, you will see the model itself, the Web2 Vec2 itself is only for one single language. But also there are other models that you can apply for multi-language ASR. And I think that's super cool because before, if you need to train a model for one specific language, then you probably would need to like manage multi-models. And later on, if you got the chance to have a multi-language ASR, then probably you can have one model and apply for several use cases. So these are the open topic. I don't have like the best answer right now because the use case that I'm sharing is with English. So really happy to dive deep if you have any question on the session or later on, if you tried out other language like German, French, I don't know, Italian, or Portuguese, other use case, feel free to share with me. And then I put several learning resources here. The learning resources contain a few GitHub samples where you can start with, where you can find a blog post, where you can dive deep on the SageMaker HuggingFace documentation, include API details, what other parameters you need to put in, and also the more posts on HuggingFace on AWS. So for me, the most interesting me is now we see more and more like open source framework that actually bringing awesome knowledge about using NLP, computer vision, audio, machine learning, and so on. So I think it's really great to see the different frameworks and you can have the capacity to run locally or things on cloud. So these are the posts and resources that I'm sharing. And this is the last slide. If you want to reach out to me, the QR code to LinkedIn profile. And thank you, everyone.
Thank you very much, Mia, for the talk. Are there any questions?
Thanks for the talk. Yeah, over.
Yeah.
Just wanted to know what the latency of the ASR model was on this for hosting it via a SageMaker endpoint.
Yeah. For this one, it will depend on your payload. That means how much seconds that you send over. And for the case like the one that I just showed, I think it's within 3 seconds. So you can see it responds quite fast. And if you have like several minutes or hours, then you probably would consider it if you want to like chant it as a small amount so that you can do it in parallel and got the whole transcription back faster. So it depends on the payload that you send over. Yeah.
Thank you very much for the talk. A very brief question. Any challenges in how to label your data, for training?
Yeah, I see the challenges there would be one case that I found in Europe. Actually, we are from everywhere. Like for instance, I'm from Taiwan. So when I work, I speak English with my like Taiwanese accent. And then that's also the case that some of my customers mentioned about. They are building a model for Italian accent English model. So the accent topic is kind of a challenge that I generally see right now, right? Because for the data set I just showed you is perfect English, it's US English or UK English mostly you can find. However, like in Europe in general, that's what I see as one of challenge. Another one is, as you mentioned, like what are the things that stop us to do annotation and things like that. The CTC model that I'm referring to is already the minimum effort you need to prepare because you don't need to map the timestamp and also the audio file. So this already make the annotation life way more easier. However, the accent part, I don't have like great answer yet. Probably, I don't know, we need to have a room, let everyone in the room speak something on that, and then we make a huge data set together. Yeah.
We're running out of time, so just one more question.
Thank you very much for the talk. It's a slight diversion maybe, but I'm curious because I've been going into NLP relatively recently, and this was a lovely introduction because I've never done anything with live audio. I can see that I could use this to get the transcription to try and do something like emotion sentiment analysis on the other end, but I'm thinking there's also information in the way somebody said it. So I'm curious, is there any models that you're aware of that will start to project of this is an angry caller coming through just from the intonation, not just the literal language they use?
That's a good call out. Actually, when we said sentiment analysis, like usually we do speech to text and then analysis what these people said literally by word, right? But sometimes we can talk differently, like, hey, I really hate you. And it's like, which one? I'm happy, I really hate you, or somewhat. So I also find that this is really challenge us regarding to content management. For instance, if you have kids at home, you probably would play some video clips for them. But there are some like YouTube videos that are playing the things like what I just referring to. Oh, I'm so happy today, I'm going to kill the person. And the parents, they're not aware of that. They heard the sounds, it's like happy sound. But what they said, literally, the parents just watch the dish behind, they don't aware of what's the context out there. So when we do the content analysis, it's important to do both. So the audio emotion plus what's the sentiment under the hood, and then you do cross-check and make the life is more real world instead of like you're just guessing this people is happy or not. And also bring along the context sometimes, because sometimes people will speak opposite when you just analysis from a single sentence. But if you do the parallel or with the conversation context, then you know when people say this sentence is based on this context. So you have a positive, negative. Is it really negative? Or it's kind of they are presenting their positive in different way. So bring the context along would also help with that.
All right.
I hope
Thank you
that's
very
all
much,
question.
Mia. Any questions, you can just talk to her.